Hello and welcome back to another chemistry tutorial with me, Miss T. Today's lesson is on ionic formulae, which is where the most common mistakes across A-level and IB chemistry are made. Now, in order to successfully write the ionic formulae, we need to first do a quick GCSE chemistry recap. We know that atoms become ions to achieve a full outer shell, and we can determine what charge these ions will have by considering the simplified 288 electron configuration notation. So for example, sodium as 281 will lose one electron to become an Na plus ion. Aluminium 283 will lose 3 electrons, become an aluminium 3 plus ion. When we go over to the nonmetals, nitrogen 2.5 will want to gain 3 electrons and so will become an N3 minus ion. And fluorine 2.7 will want to gain 1 electron to become an F minus ion. Now, when it comes to naming these ions, for the metals, they just keep their names. So sodium becomes the sodium ion and aluminium becomes the aluminium ion. For the non-metals, their ending changes to "ide" when they become ions. So nitrogen becomes the nitride ion and fluorine becomes the fluoride ion. Now, rather than have to write out all of these electron configurations individually when we're trying to determine the charges for the ions, we can use the group numbers, which tell us the number of electrons in the outer shell, to figure out the charge of the ions. So if we're in group 1 electron in their outer shell, so they'll want to lose that 1 electron to have a full outer shell, and therefore all elements in group 1 will want to form 1 plus ions. Same for group 2 electrons in its outer shell, so they'll want to form 2 plus ions. We'll now skip the middle section, the D block, and come back to that. Group 3 electrons in their outer shell, so they'll want to lose those 3 to become 3 plus. Let's skip ahead to group 7. They'll want to gain 1 electron to become 1 minus. In group 6, gain 2 electrons to become 2 minus. And in group 5, gain 3 electrons to become 3 minus. Group 4, they do their own thing. And the transition metals, our D block, as we mentioned before, they have variable oxidation states. So we can't determine the charge of the ions just based on their position. Instead, we would be told those charges or oxidation states within the question itself. So we'd be given that using Roman numerals. So for example, iron 2 tells us that it's the iron 2 plus ion, or iron 3 tells us that it's the iron 3 plus ion. There are some other ions that we can't determine their charge directly from the periodic table because they don't just consist of one element. So these are often end in 8, and the 8 tells us that there is oxygen involved. So sulfate is SO42 minus, carbonate CO32 minus, and nitrate NO3 minus. We've also got the hydroxide ion, which is OH minus, and the positive ammonium ion, NH4 plus. Now you need to just know these off by heart. So if you don't know them already, I'd recommend pausing the video now and writing down the names and the formulae for the ions in question. So now we've got the ions, we can put them together to produce the ionic formulae. So worked example 1, write the formula for aluminium oxide. So first we need to identify which ions are involved in aluminium oxide. Well, we've got the aluminium ion, Al3+, and the oxide ion, O2-. Now putting them together, we need to make sure that their charges cancel out. So in order to do that, we would need 2 lots of the aluminium 3+ ion and 3 lots of the oxide 2- ion, because that gives us 6+ and 6-, which would cancel out. Simpler way or a shortcut to determine the charges is just by swapping the numbers over. So we'll give the 3 for the aluminium 3 plus over to the oxygen, the 2 from the oxide over to the aluminium, and so we end up with the formula Al2O3. For our second worked example, copper 2 nitrate. So again, which ions are involved? Well, we've got copper 2, which tells us it's copper 2 plus, and the nitrate ion, one of our molecular ions to know, NO3 minus. Just like before, we can determine how many of each we'll need for them to balance out. So in this case, we would just need one Cu2 plus ion and 2 lots of NO3 minus in order to have 2 plus and 2 minus and for them to cancel out. Or the shortcut way, we can just do some cross multiplication, give the 2 from the copper over to the nitrate, give that invisible 1 from the nitrate over to the copper, and we end up with Cu with an invisible 1, and then NO3 2. Notice that we need brackets around the NO3 because we want 2 lots of the whole NO3. If we don't have the brackets, that would look like we had 32 oxygens, which we definitely do not. For our next two worked examples, we're making sure that we can name compounds from their names. So MgS, we are dealing with the magnesium ion and the sulfide ion. So the name would just be magnesium sulfide. For our next worked example, FeSO4, well, the SO4 we know because we've had to remember it is the sulfate ion, which is SO4 2 minus. Now, because there's only one Fe involved, that tells us that the charge of that must be 2 plus. So it must be the iron 2 ion. So the name is iron 2 sulfate. So now it's your turn to practice. Pause the video now and then press play when you're ready with your answer. First question, nice straightforward naming. So just lithium chloride, sodium oxide, copper 2 carbonate. As we know, carbonate is 2 minus, so that copper must be 2 plus, and ammonium hydroxide. Next, we are writing the formulae for these ionic compounds, and we can use our cross multiplication trick. So calcium fluoride, Ca2 plus and F minus, will give the 2 over to the F, will give the invisible 1 over to the calcium, and so we end up with CaF2. Potassium nitride, potassium K plus ion as it's in group 1, N3 minus ion as nitrogen is in group 5. Swap those numbers over and we end up with K3N. And finally, aluminium sulfide, just like the aluminium oxide that we did as a worked example, Al3 plus, S2 minus, swap those numbers over and we get Al2S3. And our final question, very similar to the last one, but now dealing with some molecular ions. Lithium hydroxide, lithium is 1 plus, hydroxide is 1 minus, so it's a nice straightforward LiOH. Barium nitrate, barium 2 plus and NO3 minus, so BaNO3 2. And finally, ammonium carbonate. Ammonium is NH4 plus, carbonate is CO3 2 minus. So we give the 2 to the ammonium and the invisible 1 to the carbonate. And so we get NH4 2 CO3, making sure that our NH4 is in brackets. So it's clear that it's 2 lots of the ammonium ion as opposed to 42 hydrogens. Be extra careful with your lowercase and capital letters. Each element must start with a capital letter. So how did you do? Let me know down in the comments. And if there are any other topics that you really want a mini tutorial on, please let me know there as well. See you next time. Bye.